Welcome to Section 3. While having our class inside the main Arduino sketchworks, it's not very professional. As your projects grow, your main file will become cluttered and hard to navigate. In this section, we will learn how to organize our classes like professional developers. Right now, if you want to use your LED class in a different project, you have to copy and paste the entire class code. This is inefficient and makes updating your code a nightmare. We need a way to make our classes truly portable. We are going to split our code into 3 distinct files. The header file tells other parts of your program what the class can do, while the CPP file contains the actual code for how it works. Your main sketch will then stay clean and focused only on the high-level logic. We will start by creating the header file, move our logic to a source file, and finally, I will show you how to turn your code into an official Arduino library that you can use across all your future projects with just a simple include line. Ready to clean up your workspace? In the next lecture, 03.02, we will begin by creating the header file for our LED class. See you there. In this lecture, we start our organization journey by creating the header file. Think of the header file as the interface or the menu of your class. It tells the compiler and other developers what your class can do, without showing how it actually does it. A header file usually has a .h extension. Its primary job is to hold the class definition, including the attributes and the function prototypes. It acts as a contract between your class and the rest of your program. To create a new H file in project folder, first you need to click on this button. Then you click on New tab. You name new file like me here, and click on OK. Now we are here. Whenever you create a header file, you must use header guards. These preprocessor directives if def, define, and in diff prevent the compiler from including the same file twice, which would cause errors. It's like a safety lock for your code. Inside LED.h, we define our class. Notice that we only provide the function names and parameters here, followed by a semicolon. We don't write the actual logic yet. That's the job for the source file. Now that we have our interface defined in the header file, let's write the actual logic. In the next lecture, 03.03, we will create the CPP file to implement our methods. See you there. Now that we have our header file acting as the interface, it's time to build the engine. In this lecture, we will create the .cpp file, also known as the source file. This is where the actual logic for our LED class will live, keeping the implementation details hidden away from the main sketch. First, we create a new file named LED.cpp. The very first thing we must do is include our header file. By using double quotes instead of angle brackets, we tell the compiler to look for the file in our local project folder. To tell the compiler that these functions belong to our LED class, we use the class name followed by 2 colons. This is called the scope resolution operator. Without it, the compiler would think these are just regular global functions. We then complete the rest of our methods, off and turtle. Notice how the logic is exactly the same as before, but it is now neatly tucked away in its own file. This makes our project much more modular and professional. We have successfully separated the interface from the implementation. In the next lecture, 03.04, we will recap this structure and I will show you how to read and use these files effectively. See you there. Great job! Now that we've split our code, let's take a moment to recap. Understanding how to read the interface is key to using classes created by other developers. You don't need to know how the engine works to drive the car. You just need to know how to use the steering wheel and pedals. Remember, the .h file is the interface that lists the methods available to you. The .cpp file is the implementation. It contains the logic. As a user of a class, you'll spend most of your time looking at the header file to see what commands you can call. To use our organized class in the main sketch, we simply include lead.h at the top. This tells the compiler about the lead class. From there, we use it exactly like we did before. Notice how clean our main file remains, no bulky class definitions getting in the way. When you download a new library, the first thing you should do is open the .h file. Ignore the private section and look straight at the public methods. This tells you exactly how to interact with the component. It's the ultimate documentation for your code. You've mastered project organization. But what if you want to use this lead class in every project without copying files? In the next lecture, 03.05, we'll turn this into an Arduino library. See you there. In this final lecture of Section 3, we are going to take your organization to the professional level. We will turn our lead class into an Arduino library. This allows you to use your code in any future project just like you use the built-in libraries, like Wire or Servo. To create a library, you need to navigate to your Arduino libraries folder. Create a new folder named leadlib, and move your lead.h and lead.cpp files there. This centralizes your code, so all your sketches can access it. In Mac you can find the Arduino folder by opening the Documents folder. If you don't know how to open the Documents folder, you open the Finder, then you follow this image. Every library needs a metadata file called library.properties. This file contains information like the library name, version, and author. It's what the Arduino IDE uses to display your library in the Library Manager. Now, in any new sketch, you don't need to copy files anymore. Simply use the angle brackets with the include directive. Your lead class is now a permanent part of your development toolkit, ready to be reused in any project you imagine. You've officially leveled up your coding structure. Now that our software is professional, we need the hardware to match. In the next section, Lecture 04.01, we will build the physical circuit for the course step by step. See you there.